Today we want to talk about the unit circle. What the heck is a unit circle? Why do we even care about the unit circle? Well, believe it or not, when we get down to this circle, we'll be able to talk about things like sound waves. We'll talk about microwaves. We'll talk about any kind of wave, because everything that is in electronics or even my voice travels in waves. The waves are when we take this circle and we unwrap this circle. So it's really kind of a very important application. In fact, Mackenzie, as you're using your phone right now, it is using tons of microwaves to basically make your phone work, okay? So let's put that down and let's see how it works, okay? So first of all, the word unit means one. So the radius of this circle is 1. Keep that in mind. So we know the radius of this circle is 1. Now technically, this circle comes from the graph. It's really this big. And you don't have to write this down. It really is a circle on the grid. It's a radius of 1. And if it's on the grid, then of course this point's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So this circle that we're going to draw is really this little. But the problem is there's so much to put on this that we actually want to blow it up and take a look at it from here. But we've got to remember that this came from the grid. So this is my x-axis and this is my y-axis, right? Okay, now a couple of things that we do know on this one is because it's a circle, it's going to have 360 degrees in it. So we know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then of course back to 360 degrees, right? So you can go ahead and put all the angles in there, okay? And if that's all we wanted to talk about, it would be pretty boring, okay? We need more. We need more information. So one of the things we can do is put in a 40, 0, 90, 180, 270, 270, and then back to 360, okay? Now, let's put in another angle because we need more information. So if I put in this angle here, let's make a 40, in the middle. So let's make a 45 degrees, exactly in the middle, okay? So let's make a 45 degree angle, okay? Well, what happens, and I'm going to draw this with my pencil, I don't want you to draw this next one because I'm going to erase it, is if I were to take a look at this point and draw a right triangle, okay, see the right triangle I drew? It is a 45, 45, 90 right triangle, right? Yeah, and so we just looked at that. We know that the radius is 1, right? It's exactly this triangle right here, isn't it? So the length is square root of 2 over 2. This length is square root of 2 over 2. If it was a point on the graph, it would go over square root of 2 over 2, up square root of 2 over 2. So it would be a coordinate of square root of 2 over 2, square root of 2 over 2, right? That would be its x and its y coordinate. So right here, we want to add that. It has a coordinate of a point out square root of 2 over 2 and up square root of 2 over 2. That's the coordinate of its point. Okay? Now we could draw another 45, 45, 90 triangle, but on the other side, right? And if I start from 0, it's really a 135 degree angle, right? 45, 90, 135 degrees, right? And this isn't hard. This is just geometry, right? And it's our exact same 45, 45, 90 triangle, but it's over on the quadrant 2, right? And in quadrant 2, you have to go, to draw this triangle, you have to go back and then up, right? To get to this point, you have to go back, which would be negative, and then up is positive. So it's the exact same triangle, but it's a negative square root of 2 over 2, square root of 2 over 2. Okay, so I've got the exact same triangle drawn in there. I'd go back square root of 2 over 2, up square root of 2 over 2, okay? Now again, I don't want you to draw the triangles in. I'm drawing the triangles in just to show you, okay? Because it is this triangle right here, but it's flipped on the other side, okay? So it's on the quiz, that's going to be right there.
Draw the triangles in?
Don't draw the triangles. Don't draw the triangles. And you know what? On the quiz, you get to use your unit circle. So it's all going to be there, isn't it? Now, let's draw another 45, 45, 90 triangle. Let's draw it down here, okay? And don't draw the triangles, but if you were to draw the triangles, we'd have, another 45, 45, 90 triangle here, right? And the same thing happens. Let's see what's the angles. I have a 180 plus 45. This turns out to be a 225 degree angle. So if I rotate all the way around 225, right? That makes sense, right? 90, 180, and then another 45 is 225. It is another 45, 45 triangle. So it'd be back square root of 2 over 2, down square root of 2 over 2. So the coordinate would have to be a negative square root of 2 over 2 and another negative square root of 2 over 2, right? Yeah, it's the same triangle. It really is. It's just the difference on how to graph it. If you have to go back and down, they're both negatives, right? Back and down is both negative. And of course, let's put in the last 45, 45, 90 triangle, which is here. And if I go ahead and do my little degrees, I've got 270 here plus 45 degrees more puts me at a 315 degree angle, okay? 270 plus 45. Yeah, exactly. That's 225, yeah, absolutely. And I have it up there on the board as well if you can't. But please ask. I know it's a bright sunny day, which always makes the overhead a little bit brighter than it should, but I love the sunshine. Okay, now, we also, everybody okay with what I've got so far? Oh, this, I got to put in the coordinate, my bad. This is over, down, right? To graph this triangle, go over, then down, so it's a positive square root of 2 over 2 and a negative square root of 2 over 2, okay? Does that make sense? To graph that over, positive, and then down, okay? Now, let's put in this triangle. Let's put in the 30, 60, 90, because that's also can be put in our unit circle. So let's draw a 30-degree angle. Now, I'm not going to draw it completely to scale because I need room, okay? So 30 degrees is more like here, but I'm going to draw it right about there, okay? So I'm just going to draw, and I'm going to call it 30 degrees. Whether it's really 30 degrees, I don't know. I don't care. I'm going to call it 30 degrees, therefore it is 30 degrees. Okay? So if I take a look at the triangle that is inside it, here's my little triangle. It's this triangle here, right? Square root of 3 over 2 and 1/2. So that means, don't write this down, square root of 3 over 2 and 1/2. So I'd have to go over square root of 3 over 2, up 1/2 to get the point. So the coordinate of this point is square root of 3 over 2 and 1/2, okay? Let me erase my triangle, okay? Now if this is a 30, 60, 90, there's a 60, 30, 90, so then I could draw a triangle up here at 60 degrees, right? So draw this triangle in at 60 degrees. It's the exact same triangle, but it's just standing up. We'd have the 1/2 here and the square root of 3 here, okay? So over 1/2 up square root of 3 over 2. So it would turn out to be a 1/2 and a positive square root of 3 over 2, okay? How am I doing? Yeah, let's put another 60, 30, 90 triangle here. Well, let's see, that would be 120 degrees here. That's 120 degrees. Okay, so that's 120 degrees here. And I make another one of these triangles, right? But I got to go back, which is negative, then up. So I'm going to go back 1/2 and up the square root of 3 over 2. So the coordinate here would be a negative 1/2, positive square root of 3 over 2, okay? So all I'm doing is using these three triangles all the way around. That's why I had to draw these, right? And then I'm going to have another 30, 60, 90 triangle to here, right? Okay, I'll draw this one. I'll wait for you, okay? 150 degrees, and I'll wait for Julia, okay? Okay. Okay. Yeah. Okay. So, how am I doing, Julia? Okay, so it's back square root of 3 over 2, which is a negative square root of 3 over 2, and up 1/2. That's the coordinate of that point. All right, so let's draw another 30, 60, 90 triangle here, right? Draw another one here. That's a 30 degrees, so that makes this a 220 degrees, right? And if that's a 220 degrees, I get another triangle in here. It's going to be back square root of 3 over 2 and down 1/2. Square root of 3 over 2 is the longer length. Does that make sense? So way to remember, 1/2 is the shorter length. Okay, so back square root of 3 over 2, down 1/2. So they're both negative. It has to be a negative square root of 3 over 2 and a negative 1/2. Okay, that's according to that point. All right, and then down here, I've got another 60, 30, 90 triangle, right? So this angle is 240 degrees. And the coordinate of this point is at back 1/2, down the square root of 3 over 2.
Is that a 210 or a 220?
220. Oh, it should be 210.
Yeah.
It should be 210. Thanks, Grace. You found my mistake. 210 is right. Thank you, Grace. I did make a mistake.
So what happened?
This is a 210. That's,
Instead of 220.
yeah, 220. It's got to be 210. I got to be able to, 180 plus 30. Come on. Come on, Talis. You got to catch my mistakes.
So every time you add by 45?
I added 45s here,
And now
here, here. Now I'm adding 30s. I'm going 30, 30, 30, 30, 30. So I'm skipping the 45s and just adding 30s. Does that make sense? I'm skipping the 45s are in the middle, okay? And of course, Alondra, we're going to put it all down and then you'll have it. You don't have to worry about it, okay? You will never have to recreate this, okay? You're going to keep this. Numbers are going to be good. You don't have to worry about it, okay? So this is going to be negative 1/2 and a negative square root of 3 over 2. Negative 1/2, negative square root of 3 over 2. Let's draw another 60, 30, 90 here. It is going to be a positive 1/2 down the square root of 3 over 2. Positive 1/2, so it's going to be a positive 1/2 down the square root of 3 over 2. And then that's got to be a 300-degree angle. And then finally, the last one is going to be a 330-degree angle. So I'll draw that one in here. There's my 330-degree angle. And we'll have a square root of 3 over 2 and down 1/2, okay? All right, there's our circle, okay? And if you don't have it completely, it is up here. It's a little bit smudged because it's been up here. It's been up here all semester, hasn't it? It's been up here a long time, right?
Oh my god.
Okay. Are we good?
No.
So, what I want you to do now is add. Are we good? I'll wait for you, okay? Now, why don't you wait, okay? Now, what does this have to do with trigonometry, okay? Has a lot. You guys got it? Micaiah?
35, and then 330
330.
to the left.
315. 315. And then 330.
Yes, 315, not 315.
Okay, got it.
You got it? Okay. How am I doing?
Okay.
All right. Now, let's take, as soon as this is done, we're going to take this away and we're going to look at our other notes, okay? The notes I gave you, all right? Let's see where to get those notes are. Where's those notes? Where did I set those down? Oh, where's the other notes? Pass them out.
Write the high stuff up there.
We will eventually, yes. That's coming. All that's coming real quick. All right, we're gonna put them.
Mr. Davies, you're still alive.
Huh?
You're still alive.
I'm still alive. Yes, I am. Are these the extras? Well, there they are. What were they doing there? Okay, so you ready? Let's take a look at this sheet, okay? Now, if you need... Let's see, do I have any more copies? I don't know. Anyway, let's take a look at this sheet, okay? Anybody else need one to look at? Okay, good. I'll hang on to this one. Okay, let's take a look at this, okay? So, before I even start this, what we're going to talk about, Common Core Standard, is how to talk about what are radians, okay? Radians. And in your calculator, you have that mode button where you can go from degrees to radians. Well, before I even talk about radians, let me show you why radians are important, okay? So a little example up here, okay? In geometry, watch. I don't want you to write this down. I want you to just watch, okay? In geometry, we were told that as if this was a 30-degree angle, that this arc was also 30 degrees, right? Remember that from geometry? So that means if this angle was 30 degrees, then this arc was 30 degrees, right? We're told in geometry, and I wasn't lying to you, that if this angle is 30 degrees, then this arc is 30 degrees, right? We were talking about that in geometry. However, there's a big problem with this, something that really bothers me personally, and that is if I look at the lengths of these, they say 30, 30, 30. That bothers me because they're all different lengths, right? So if we want to find an arc length, we have a formula. Arc length formula comes from the circumference of a circle. So what we want to do is this. To get radians, okay, listen carefully. To get radians, we need the arc length to be equal to the angle, because this 180 degrees doesn't mean this length is 180 degrees at all, okay? We need the length of the arc to be equal to the angle. This is not 180. That length is not 180. However, this length right here is, you ready? Drum roll. This arc length is 3.14 blah, blah, blah. If I were to take a piece of string and wrap it around here, unit 1, this is radius is 1, okay, and go like this, measure it. This length is 3.14 blah, blah. It's pi. So now what we're going to do is this. We no longer want to call this a 100-degree angle. We're going to call this an angle called pi. They have new names. This angle 180 degrees has two names. This angle has two names, 180 and pi. They're both the same angle, two different names, 180 degrees, pi radians. Why are the radians so darn important? Because the angle refers also to the arc length. This angle of pi also refers to its arc length. Well, if this is pi, then halfway has got to be pi over 2. So 90 degrees is pi over 2. So the length of this, is whatever the decimal equivalent of pi halves is. I don't know. Hold on, I'll check in a second. Hold on. Pi divided by 2. This arc length is about 1.57, okay? We want the angles to measure the arc. So now, this pi halves is an angle. It is an angle. 90 degrees or pi halves radians, okay? All right, this angle down here is 3 pi halves. Okay? It's no longer 270 degrees. Degrees for dummies. We're not dumb. It's 3 pi halves radians, okay? 3 pi halves is the angle. This is an angle. 3 pi halves is an angle. It's the same as 270 degrees, okay? If I go all the way back around the circle, that's 2 pi, right? That's like 360, okay? Now, what about 60 degrees? Well, 60 degrees is a third of this pi. 60 degrees is a third, so this is pi thirds. It's an angle. Pi thirds radians, okay? Okay, this angle is 2 pi thirds pi. This angle at 240 degrees is a 4 pi thirds. This angle here at 300 degrees is a 5 pi thirds. Okay? These are angles. They're called radians. They're called angles, okay? So, let's go back to our notes. All right? Let's go back to our notes. I'll put the circle back up, Grace. Let's go back to our notes, okay? So, let's go back to our notes, okay? Radian is an angle measure that relates its arc length and center length, okay? If the radius is 1 and the arc length is 1, then this angle right here, theta, is equal to 1 radian. Okay, that's the definition of a radian. 1. The angle itself is 1 radian. Okay, now what we need to do is some equivalence. Okay, here's what I know. 180 degrees is equal to pi radians. We talked about that. 180 pi, same thing, right? 90. What did we write? What was 90? What did we write for 90? I think we wrote pi over 2. Good. What did we write for 60? What was 60 degrees? Pi over 3. Totally right. But what about 45? What would you think 45 would be?
Pi over 4.
It's up there, isn't it? It's pi over 4. Totally right. It's pi over 4, okay? What about 30?
Pi over 6.
Pi over 6. It's actually up there, isn't it? Pi over 6 because it's a sixth of the 180, okay? How about 120? It's up there, right? What's 120? It's on the unit circle. 2 pi over 3. 150 degrees. It's on 5 pi thirds. Oh, 6. My bad. 135 degrees. 3 pi over 4. 210 degrees. 7 pi over 6. Thanks, Alondra. 225 degrees. What's the radian measure?
5 pi over
5 pi over 4 is right. 240 degrees.
4 pi.
4 pi over 3. 270 degrees. 300 degrees. 5 pi over 3. 315 degrees. You're getting used to saying pi instead of p. 360 degrees? What do you think 360 is? No, 360.
Oh, 360.
2 pi. So now if we want to fill in our... I didn't put it on there, did I?
Yeah.
No, it's all good. But we can put it on there. See, now we can add them all in, right? 135 is 3 pi force. 150 degrees, 150, I forgot to put my 150 in here. 150 degrees is 5 pi 6, right? 210 degrees is 7 pi 6. 5 pi force. 7 pi force. 11 pi 6. There it is, Talus. And back to 2 pi, right?
Yeah.
Pi 6, pi force. Okay, they're all up there. If you don't hear anything today, if you don't hear anything at all today, hear this. If you hear anything at all today, hear this. These weird pi thingies are angles. They're angles. They do, however, help you with the arc length, but they're angles. That's an angle. Pi is an angle. It's 180 degrees, sure, but in radians it's called pi radians. It's an angle. Pi thirds is an angle. Yeah, it's 60 degrees also, but it's an angle, okay? Keep in mind that it's an angle. And the reason it's so important that it's an angle, go back to my original drawing when I drew those degrees, right? If you had a real life situation like this, and we do have a cell phone, and your cell phone sends a signal, right? The x-axis has to be time. Has to be time, which is a length, right? Your x-axis is a time. Your time has to be in terms of like numbers or decimals, not in degrees. That's why we use radians. So the application works, okay? All right, now, Grace, you can look at this later. Now, what about this? If I go to my unit circle, I've got my 30 degrees, my 45, but I don't have all of them. I drew everything in here. If I drew a 10 degree angle in here, if I drew a 20 degree, it would get way too crowded. You guys agree? Way too many angles. I mean, this is enough. This is way too much already. You guys agree? It's like, holy smokes, Steve, that's a lot of angles. Okay? But if I wanted a 10 degree angle, I've got to have some kind of conversion because I've got too many. So here's what we have. We have a little formula, okay? So our little formula is this. If we converted 180 to pi. We get that from the circle. 90 pi halves, we got that from the circle. But what happens if it's not in the circle? We have a conversion. It's very simple. Check it out. Okay, be awake for 5 more minutes, okay? If I want to go from degrees to radians, I have a little formula. It says degree over 180 times pi. So let's do example 1. If I put 20 degrees in here, I can convert it. So I'm just going to put 20 here. I'm going to go radian R equals 20 over 180. I'm going to put those 20 here. 20 over 180 pi, okay? And then I should reduce this. And if I reduce this, my radian is going to equal 1/9 pi, or pi ninths is a better answer. Now let's say, and raise your hand, be honest, how many kids absolutely do not do fractions? I do not do fractions. Raise your hand. Okay, check it out. A calculator does. You guys are going to love it. So you know what? Let's say I've got 20 divided by 180, right? I don't do fractions. I do not do fractions. But you know what? Check it out. In your math button, your calculator does fractions, and it'll reduce this to 1/9 for you. So I'll do it again. If you had 20 divided by 180 as a fraction, you go to your math. Grace, watch. You go to your math button. There's your fraction. Reduces it for you. Isn't that nice? Okay. Okay, now, how about this one? Negative 260 degrees. We'll do the same thing. We'll take our negative 260 degrees and put it in for D. So we'll say, all right, R for radian is equal to negative 260 over 180 pi, right? And that will reduce 26/18, 13/9, but let's say you don't do fractions. Hey, Mr. Davies, I don't do fractions, okay? So you go, okay, I can handle that. Negative 260 divided by 180, right? Go to your math, do a fraction, negative 13/9, okay? It will reduce for you to negative 13 pi ninths. That's the radian equivalent of your 260 degrees, okay? Now we can go the other way. If we were given a radian, we can convert it to degrees by plugging it into the formula. So we're going to plug our 3 pi eighths in for R. So we're going to say our degree is equal to 3 pi eighths times 180 over pi. Okay, there's my conversion, right? Being a math guy, the first thing I see is I can cancel the pi's, right? You agree with that? Cancel the pi's? And then I'm just going to use my calculator and say, okay, well, what is, let's see if I can put it so you can see it better. Oh, okay, there we go. What is 3 times 180 divided by 8, right? 67.5. So this angle, 3 pi eighths, is equal to a 67.5 degrees. Same angle, different name. Same angle, different name. And finally, the last one, I'm going to use the formula again. I'm going to put this negative 7 pi 12ths in for R. So I'm going to say the degree is equal to negative 7 pi 12ths times 180 over pi. Okay. I notice that my pi's will cancel. So I'm just going to use my calculator. If I can see it on there. Now, barely. I'm going to go negative 7 times 180 divided by 12. And I can ask for negative 105 degrees. So the degree is negative 105 degrees. Okay, so there's a lot more to learn, isn't there? Okay,